Greetings, chemistry students. This is Mr. Resentes, and what we're going to talk about today is covalent bonds. I'm on chapter 7, page 236, and we've already talked about ionic bonds. Don't get the two confused. Ionic bonds are when metals and nonmetals bond as a result of the formation of ions, because metals quickly form cations and nonmetals form anions. But anyway, that's for another discussion. Don't confuse these with covalent bonds. Covalent bonds are formed when electrons are shared between two atoms. And as you can see here, phosphorus has 1, 2, 3, 4, 5 electrons in its valence shell, and the way we know that is because it's in the fifth group, and it wants to share a pair of electrons to form bonds, and in order to make 8 in its valence. And so here it is sharing the electron with the chloride. Now, molecules are formed from covalent bonds. Distinguish molecule from compound. Compounds are ionic bonds for the most part. Now, compounds are crystals for the most part. Metal and non-metal. Molecules are just formed from non-metals. Compounds are good. Compounds are typically form ions whenever you put them in water. Molecules do not form ions whenever you put them in water. So molecules are distinct from compounds. Molecules, you could break it down and have a happy molecular compound that won't further break down in water, whereas a compound will. A compound such as salt will dissolve in water. So sometimes you might hear the word molecular compound. That's not confusing, because compound just means more than one element, and molecule means something a little bit more. It means that it's usually covalently bonded, and it's a happy small group, a small compound of elements. And so that's my best explanation for that confusing term. So molecule and compound are distinct, and we should distinguish the difference between the two. Now, a molecular formula tells us how many of each element is in a molecular substance, a molecular compound, for example. Here we have O2. Tells you that there's two oxygens. And we have C6H12C6, but that's not in its lowest term. And so an empirical formula is the lowest ratio of the molecular formula. And so it would be C2O. So there's 2 oxygen. So this is in a ratio of 1 to 2 to 1 ratio. And that's the difference between an empirical formula and a molecular formula. Now, there's different types of bonds that we should describe. First, a single covalent bond. Hydrogen brings 1 electron, and so we could put a dash that indicates a shared pair of electrons. Now, in the case of oxygen brings 6. And so what'll happen is it wants 8. So these electrons will arrange themselves so that they begin to share. So as you can see, it has 1, 2, 3, 4, 5, 6, 7, 8 electrons, and this one has 8 electrons. And so they're sharing in what we would call a double bond. And so if 1 dash is a single shared pair of electrons, 2 dashes is 2 pairs of electrons being shared. And that's called a double bond. And the most you could have is a triple. You could have a triple bond, and that would, in the triple bond, you would see in the case of nitrogen, it forms a triple bond. Alright, so 1, 2, 3, 4, 5, 6, 7, 8, it has its 8 electrons, and so does this one, if you counted those up. Alright? And then what type of bonds will be formed between the two carbons in this molecular compound? Well, carbon is in group 4, so it has 4 electrons in its valence. Same, we have 2 of them. And we have 4 hydrogen, so 1, 2, 3, 4, and the hydrogens will bring an electron for a shared pair of electrons. So we have a shared pair, we have a shared pair, shared pair. So those are single bonds, and then these electrons will then form a double bond. So it would be form a double bond. Right. What are some properties of covalent bonds? Well, one important property that I'd like that you should know is polar versus nonpolar. A polar covalent bond really describes a molecule that has a side of the molecule is more electronegative than the other. So it's an unbalanced charge. So in the case of water is one of the most famous. We have a region that has a negative charge, and we have a region that has a slight positive charge, because these are protons, remember. And so we have a region that's highly negative because there's negative electrons swirling on this side, and then there's positive on this. And this angle is 104. It's a very famous angle. Because of that angle that's formed in this polarity, well, life as we know it is possible, because we've never experienced life anywhere without water, and this gives it its characteristic. It gives it characteristic solubility that it has a universal solvent. It gives it its ability to form a crystal when it becomes solid. So this polarity is extremely important. But what it means is it has a negative and a positive into it. That's basically what it means. One side of the molecule is more negative than the other. That's basically what is meant by a polar molecule. One side of the molecule is more negative than the other. That's basically what we mean. All right. Now, what we also want to be able to do is we want to name the we want to be able to name covalent bonds, and covalent molecules. My apologies. And in so doing, we need to be able to use these prefixes: mono, di, tri, tetra is 4, penta is 5, because in the case of this molecule, what you would do is you'd say it's nitrogen, because there's 2 oxygen, it's dioxide, and we already We already talked about changing this to "ide" when we were in ionic compounds. And this would be boron. There's 3 fluorides, so it's boron tri. I got tri from my prefix. Trifluoride. Right? We also talked about, remember we talked about binary ionic compounds. That means there's just 2 elements in a binary compound. Don't forget those. Don't forget the molecules that make up diatomic. The diatomic molecules that make covalent bonds, and we called those. Remember Brinkelhoff? Those are named like dioxide, because there's 2. Let's see. How about nitrogen trifluoride? Well, nitrogen trifluoride would just be NF3. Right? How about one more? P2O5. Well, 2 is di, 5 is penta, so we know we're going to have to use those prefixes. And this is phosphorus and oxide, so it must be diphosphorus pentaoxide. All right.